The next talk, you already can read it. It's about refactoring 15-year-old code. And I just give over to Anna to rock the cinema now. Thanks.
Thank you. All right. So the reason I chose this picture is because old code likes to blow up in your face. Or sometimes it's because that's what you imagine you can do to the code. You wish you could just blow it up and start over. So rewriting code. Myself, my name is Felina. I fix legacy. I rescue projects. I'm a developer, trainer, speaker, team lead, you name it. Let's talk about the code. Let's say you inherited a 10-year-old code base. Or maybe it was a 15-year-old code base. Or maybe even 17. But here's the thing about code. It doesn't age like wine. More like cheese, it gets to stink. I mean, it doesn't break in itself, but with time you start to see the flaws as you build around it. So what was the web like 17 years ago? Well, it was 600 pixels wide. This is Yahoo from 2000. And if you don't feel old yet, that was around the time of the Y2K bug. Internet Explorer 5 was getting popular. So if you don't like 6, imagine 5. ICQ was only starting to be cool. Exactly. Thank you. I was hoping for someone to do that. And also, if you could do rounded corners, which was pretty difficult to pull off in the past, that was a real status symbol. You were like the cool kid on the block. You had rounded corners. So your code was written around this time. So in the time, it makes sense that people weren't necessarily following all of the clean code standards that we talk about now. We've been talking about this for the last 15 years, but back then it didn't quite exist, at least not on the web. On the web, people kind of started over. And I get a new legacy project every few weeks, usually, and I want to share with you some of the stories and advice on how to deal with that. So, and when we talk about legacy, it doesn't mean that it was written far in the past. It could have been written just a few months ago. And that's when we call it legacy by design. So how do you identify legacy code? Well, mixed concerns. Of course, if in the same file you mix your SQL queries, and of course you don't use PDO, and then you have all your logic, and then at the end you have some HTML in it, everything in one PHP file. So that's like PHP 3, that was normal. Nowadays it's not. So you've probably seen this. Everything is in a single file, and of course there's no routing. What you had was you organize your different files in your folders, and that is the URL of. So you would have like admin/purchases.php. That was the standard. Also, poorly named variables. You find variables named just A or array of something. I don't know. Item 3. Z5, 45 maybe, I don't know, when you completely run out of letters and numbers, you start mixing things up. Another thing, who here has included a functions file before? Yes, thank you. I appreciate the honesty. And that was fine at the time because we did not have, with PHP 3, we did not have object-oriented PHP, so that was normal. Today, it would be smelly if you do something like that. Also, I often see abuse of static methods. They're not evil in themselves, but when they're overly used, you might wonder how different that is from actually including a functions file. So it's like a functions file, but just namespaced. And of course, you have some wonderful dev mode, which can be based on which file you included previously. The dev mode could be a different flag, actually. Sometimes it's true, sometimes it's not, because it depends which configuration you included. So you can never actually trust it. Just because you found its value in one file doesn't mean it's not a different value. It then gets even more interesting, and all of this is based on true stories. All of this is taken straight from the projects I worked on. I had a project where there was a dev mode, but there was also the payment gateway dev mode. And what it meant is that your application could be in dev mode, but still charging actual credit cards, because they're two different flags. Yeah, it took me a while to hunt it down. Mistakes were made. Lessons were learned, and now I'm sharing them with you. So beware of the dev mode, don't really trust it. Every script is a new script. Interesting inexplicable conditions. Also taking straight from some code. If the order ID is greater than 20,117, use this SQL. If not, use another SQL to query the database. And then you wonder, well, of course, there's no comments, there's no documentation. The developers who coded this are long gone. The code base has been purchased by another company since then. And then there were 3 more developers working on it at some time. Nobody has a clue. The thing that you wonder here is what happens at order ID 2117? There's some history behind it. Did the database schema change? Well, no, because then other things would break. Probably the way data is stored has been changed, but hasn't been documented. So now you have to, based on this time period, you either query this way or that way because data has changed and nobody bothered migrating the old data to the new way of using it. So when you find something like that in your legacy, what I recommend you do is you bookmark it, like put a fix me comment or some flag. And one day when things will go terribly wrong, the answer will probably be somewhere here. So I call this a weakness also. If you see something like that, it's probably time to refactor. So you can change it many ways. One of the best ways is probably to just standardize the data to the new format that's currently being used so that you don't actually need that if statement in the first place. Because if you're going to do other operations somewhere else and people are not aware that things are becoming different after a certain order number, then they will run into some problems. So you have to duplicate this statement everywhere, and you might forget. So this is a good place to refactor. Long methods, what it does is irrelevant, just long methods that may span pages and pages, or maybe they accept 20 arguments, which is very difficult to work with. It's just unwieldy. The average legacy code file that I have to deal with is between 3,000 and 6,000 lines of code. Half of it is commented out just in case we need it later because, people weren't quite aware of source control at the time. And even today, I still see people do that. Even though they use source control, it's just like this old habit of keeping that code in there readily available instead of just going through the history. Method lengths of 800 lines, pretty standard. Abuse of helper classes, so just static calls everywhere. And sometimes just no classes at all. Me personally, I try to keep my methods under 30 lines. However, I'm constantly trying to reduce that as much as possible. Hopefully, I will get to Martin Fowler's target of 10 lines maximum. I'm still working on that. It's still too much? All right. 5 lines max? All right. Okay. I'll keep working on that. So when you reduce that to fewer lines, basically it's easier to test, easier to debug. When something goes wrong, you pretty much have just maybe one if statement in there. So the cyclomatic complexity is really low. It's very easy just at a glance to see what it's doing. And pinpointing a bug in there is just then becomes really obvious. The other thing is about helper classes. Yes, what happens is that they're not necessarily bad in themselves, but people use them. When they use them in the incorrect context, they can create mixed concerns. So even though you separate your HTML from the logic, if you can easily go and pull stuff through static calls inside your views, then you are starting to mix concerns again, like accessing the database from your template is not a very good practice. You're still mixing concerns. So raise your hand if this rings a bell. Have you seen projects like that? All right, the vast majority. All right, so I'm not the only one. Good. The code base itself, this is one of the projects I worked on about a year and a half ago. It had 5,000 classes, 20,000 methods, and 1.5 million lines of application code that does not include the framework. And it's quite commonplace in my line of work. And it all seems almost depressing. It seems impossible to refactor these projects. But the thing is, with good methodology and good strategy, it's not that hard. So before you code, what you need is make a strategy. The way this strategy works is, and let's compare it, your code base to a house. When you want to start making changes, there are certain constraints. There are walls that cannot be moved because they support the roof. If you remove them, everything collapses. So you need to know what those constraints are, and everything else you can strip it out. You can move things around. That's not a problem. So you have to identify those constraints and make a strategy around those constraints. Then you have to decide whether you want a full rewrite or a progressive rewrite. And right here, I will tell you that full rewrites almost always fail for a variety of reasons. I would say you can do a full rewrite in the absolute worst case scenario. For example, let's say you have a code base that is compiled or encoded in a way that you cannot access the source, so you have to reverse engineer things, or maybe it's written in a language that is not supported, but even then there are sometimes things you can do. But of course, if you're rewriting something that was maybe not a web-based application, and then you need to make a web-based application, you can run into certain constraints where you absolutely have no choice. But most of the time, you do have a choice. And the way you can do it progressively is you can do it by, by method, by class. I personally prefer by feature or module, whichever way you like to call it. So a module could be maybe like a billing module for your application, which is just a part of it, but a large and self-contained enough chunk that you can tackle it all at once and not worry too much about the dependencies. You can also do it by HTTP call, because in the web, which is really nice, each call is independent from other calls. So there's no actual dependencies other than a few things that you can work around. So for example, the only dependencies may be like sharing your session, database, things like that. But everything else is just input. It's a request. It's an input, and then there's an output. So you input maybe a body, you input some headers, the URL, and then you have something come out of it. And you can assert those inputs and outputs and create tests for them. So you can rewrite that way. I often use mod rewrites, or if you use Nginx, similar also. So mod rewrite is for Apache, so you can forward individual HTTP calls to a completely different application, which has its own routing. It takes care of everything. But before you start, there are some precautions that you have to take, because you're probably going to be working a bit on the production server. You're going to have to test certain things for which you cannot recreate the environment. Ideally, you should recreate the environment, but sometimes it's not quite possible. First, you have to back up. And not just back up the data, but you have to test the restoration procedure, because maybe you did something wrong, and when you try to restore it, you do not have a valid backup, and you realize that. And there was a tweet a few years ago saying Schrodinger's backup, it both exists and does not exist until you try to restore it. So it's very important to try that at least once, because it happens once that MySQL dump did not suck in all the procedures and views, and that created a problem when trying to restore the whole thing. So certain things had to be recreated from scratch. When you start grabbing data from production, whether it's for yourself, just because you're going to have that data on your machine, because you might hand it off to some subcontractors, you might want to nullify or zero out some of the sensitive data. So things like emails, to make sure that any mailing will not go to actual clients. You can remove any private information. You can, especially if there are any plain text credit cards inside, just put like a test credit card. Passwords, yeah, plain text passwords. Remove those, and then you have still a valid data set that you can work with, that you can test out. But at least you like, if somebody steals your machine, it's not the end of the world. and also by zeroing out the credit card numbers and other things on which you can perform operations that you cannot take back. Like once an email is sent, once a credit card charge has been made, there are consequences. Therefore, if you have some fake data in that, it will be an additional safeguard for you. But yes, you still need ideally staging where you can simulate deployments, upgrade, some batch processes you want to run in there. Very important. Before you start making any changes, you have to automate tests. And I will show you an example of some ways you can automate your tests. Also make a risk assessment. Don't be too optimistic because what happens is that we think that things will be fine. We have like a best case scenario, but things can go also very, very wrong. So you have to make the proper assessment. At the same time, you have to discuss those risks with the client or whoever you're refactoring for, because they might be able to stomach certain things if they go wrong. You might think it's a catastrophe that this happens, but for them they say, no, but we have this manual process we can go through, and it only takes like 20 minutes, so it's not really a big deal. Spending 40 hours trying to safeguard against it is not really worth it. So talk to them about those risks, don't assume things, but also account for side effects, because if you have a wrong credit card charge, it's not just reverting the charge. You have to maybe undo some statements you generated, maybe emails were sent to clients already with the incorrect data, the incorrect invoice. So you have to contact the people, maybe you overcharge them. So you have to apologize for overcharging. So there might be a lot more work as a side effect of something. So you have to account for all these. So at the same time, don't be too optimistic, but weigh those risks with the client. And when I talked about the legacy data, why it's important to build with real legacy data, and this has happened to me recently on a project, don't try to create legacy data based on your understanding, because you might think you understand it, but maybe you don't. And if you don't have a real DB dump, then that garbage data that you have created can bite you. Or rather, garbage data in the real database might be accounted for by the legacy application, but you might not be aware of those things and you might not have safeguards against that. So there can be a lot of problems arising from just assuming how the data should be. You assume that this data is correct. You assume that this thing does not contain empty strings, but what if it does and suddenly everything explodes? You're getting the wrong status codes because of that, maybe. Here's an example. So I said I will give you concrete examples of rewrite operations. So this is a failed rewrite. Well, it's both. It was initially failed, but then we did a better rewrite. So it was an application written in PHP 3. It was purchased from another company. So it changed hands a few times. There were, HTML, PHP, SQL, all in the same file, mixed concerns. Includes all over the place, that dev mode I mentioned earlier, that's from there. The if order ID is also from there. It's my source of inspiration for these talks. And somebody tried to do a complete rewrite of that application. And the application didn't seem that big, but it actually kind of was. There were a lot of little hidden things in there that people weren't aware of. And so they underestimated the effort, started rewriting, but also rewrote with bad practices, which made it even worse. So it was not only a failed attempt, but now they ended up with duplicate code, or parts of the code were dead now, but we didn't know which one was the correct code. So folders of that code, classes with a bunch of static functions, no instances. So what was the point of using PHP 5 at all if you're not going to use any of the object-oriented stuff in there? And basically, yeah, just classes that acted as namespace for functions, no proper objects. And this reminds me of another thing that happened over 10 years ago at a company where we outsourced something and we asked them to write it using object-oriented approach. And the code came back. It was one class. It was a class, but it was one class and everything happened inside. basically like a main, you know. And a colleague jokingly said, he said, but it is object-oriented. We have an object, now we just have to orient it. I really like that joke. Thank you. Right, so the solution for that was to rewrite some of the more complex forms. There were like multi-step forms there. We rewrote them to Symfony, used mod rewrite for the concerned pages to forward it to like another project folder, and then had internal routing match that. So we didn't actually disrupt anything in the application. Basically, that specific URL is served by a completely different application, but it ties into everything correctly, into the database and into the sessions. So we rewrote the biggest module. The biggest module was a batch system that processed invoices every week. So yeah, we rewrote that part, and we use something called design extraction, which I will cover in a moment. So by doing it properly, we had more flexible architecture, we automated the tests, and that was really the only thing that needed to be rewritten, just the biggest module and some of the multi-step forms, and the rest was actually working quite fine. It was pretty simple, so we didn't have to rewrite it quite yet. Eventually, but there was little business value in doing so, so the client wouldn't necessarily want to pay for that. And how do you measure, you know, what's the size of the rewrite or the module that you can tackle? Well, if it takes more than a sprint, then split it into smaller chunks. Rewrite something you can finish within one sprint. And I see nodding, so that's very reassuring. So yeah, that invoice calculation module took one person 40 hours to rewrite. So it was an obvious choice. And those 40 hours not only saved a lot of money because there were mistakes in the code originally that were eliminated. So by eliminating bugs, they were making more money. And also additional features would require a lot less time to implement from now on. So design extraction, how does that work? The client is usually the only one who knows how things are supposed to work, but nobody really knows how things were implemented. Because as I said, code changed hands, no documentation, nothing. If you try to rewrite the code, just look at the original code and try to rewrite it one for one, you'll be biased by how the current code works, not how it's supposed to work. So you will probably reintroduce the same bugs and flaws into your new application. So to avoid that, and to avoid, you know, copying bad architecture into just like a new framework, you do design extraction. So what you do is you take the old code, and from that you write the specification. So even if it's flawed, it's fine. You just write the specification of how the code is working right now. Then you go and you validate that design with the client. So you see the client or whoever sponsors the project, you validate those design documents, and you come up with new design documents, a better architecture. So you basically fix the bugs in the requirements, you think of a more flexible architecture, and then you, at this point, what you have is a brand new specification, and you can throw away the rest of the code. It's the other codes and the other design document is irrelevant at this point. What you have is a new specification, and you just need to write new code for it, completely from scratch. Not the whole application, right? Just the module you're trying to rewrite. And that ensures the best possible quality for the new code. It reduces technical debts, allows you to extend functionality much more easily, and you avoid all of those mistakes that were made in the past. And you can clarify the business rules by designing ERDs, flowcharts, decision trees, very useful for validating some of the different if statements. And you can call them to discuss and revise the documents as many times as you need to arrive at an optimal result. Now, I usually say if you touch legacy, any legacy that you touch, you have to improve the part that you touched. Because you already spent time reading this code. Why bother reading this again? So you touch it, you refactor it. So try to improve it as much as possible, and that will progressively remove technical debt. And it will also make the whole job of refactoring a lot more pleasant, less daunting. It's not like, oh, we're going to have to rewrite this whole thing. No, we can just rewrite sometimes just a small method at a time until we come up with a better plan. Because sometimes you just have to fix a bug now. You don't have time to refactor the whole thing. So when you start debugging, the first thing you have to look at is code duplication. And it happened to me on a project where a bug has been repeated 80 times. Because they had essentially the same code, but they just, for the small variations, they copied it over and just make those changes. So when there were bugs and the files were slightly different, so you couldn't just regex replace things. So you have to manually go through 80 bugs. But then there were multiple bugs in each, so you had to do a lot of operations. So first thing you can do is just remove the duplications. It's actually faster to deduplicate the code, just create one file that does what you need it to do, one class, and then just make the fixes in there. It's going to go faster. So because these code duplications will bite you really hard. If you forget just one, you would not necessarily be able to test everything properly, and you'll just leave bugs in the system thinking that you have fixed them. So, thank you. What you have to do after that is look at long methods. So we deduplicated code. Basically, we try to reduce the amount of code running. What you can do when you have to fix a long method, let's say you have a method of 800 lines and you need to fix that tiny bug. You pinpointed the bug, you know it's here. So what you can do is write a test for the entire method, but not necessarily covering all the paths. Try to cover as many as you can. Just write a few inputs and outputs for that. And just for like a sanity check, when things go terribly wrong, you'll quickly get something on your console saying, hey, you completely messed it up. So at least you have like a safety net. Then you take the broken part and you extract it into its own method. And I'll show you an example of how that works. And then when you extract the broken part into its own method, which you then call from the other method, you write a unit test for that part. You write a test that basically fails, right? Then you fix the bug and now the test passes. So now you have unit tests for something that is rather small, and you know that this bug will not come back again. But how do you decide where to split, right? How do you split your method? There are almost invariably logical groups within your method. You usually have what? A block of code without spaces, right? And on top, you have a comment explaining what this block does. And you have just a sequence of those. So this is it's not always like that, but it's very often like this because, you know, this block does something very specific, and that is how you know that this should go into its own method, because this does one thing, this does another thing, and you can summarize it in the comments. You spot the logical groups. Let's say you have a comment says, well, this block of code converts a CSV to an array of conferences. So we're reading some list of conferences, you know, where they are, which city, and we're going to convert it to an array. Then for each item, we're going to get the coordinates, right? And then we're going to save those coordinates to the database. And when we do that, we then can put things on the map, right? Because now we have coordinates and we can see all the conferences where they are. So what you do is you extract that block into its own method. And then, as I said, you do the whole unit testing. And you can just repeat it as many times as you like, as many times as you need. So one broken part at a time. If you have some more time, you can refactor the whole thing. How do you name those methods? Usually very similar to the comments that was on top, because the comment says, most people, what they're going to write in the legacy is what this does. Well, that's the name of the method. This one is get conferences from CSV. Just come up with a standardized way to do it. Get conferences from CSV, get location coordinates, and then save conference. And that's it. That's actually pretty straightforward. And you'll have the slides on Twitter, so you'll be able to follow those methodologies. Rewrite example number 2, ASP Classic to PHP 5.6. So it's a 15-year-old code base. The language is no longer supported. So not even security patches, nothing. It's dead. So the application was open to all the vulnerabilities. It's a huge ERP with lots of code, hard to rewrite all at once. So I came there to consult with them, and I came up with a solution. Just rewrite page by page to Symfony, because they already knew they wanted to move to PHP and Symfony. And then, once again, mode rewrite for the concerned pages. Because of the way ASP Classic stores its sessions in like its own container, it was not something that PHP could access. So what they did is they wrote a session adapter in both applications that would write to the same database, to the same table, and that's how the sessions were shared. So now the PHP application is basically authenticated as the same user because all the cookies are shared, it's all in the same domain. So it's actually much simpler than they thought it would be. And the thing is, the page in any language is an HTTP request. An HTTP request is a unit, therefore you can test it. So you can do some guzzle testing, for example, or bhat. So what we did is we wrote a test which would prepare an HTTP request and send it to the ASP page, so the legacy application. And then we check the response. And then for that, they're going to replicate the code in PHP, or at least match the output. And we would, the same request, we would send it to the PHP version and then compare if the outputs match. If they match, perfect. Of course, it's going to be like ugly HTML. That doesn't matter. Try to match it as much as possible. And then when you've finished rewriting those things and you validate that they're good, that everything passes, then you can go on and slap a new design, because now everything is properly separated into templates, so you're not going to have a problem there anymore. And regarding testing, it's very important, and I wrote a poem many years ago. Before you code, you better test so that on weekends you may rest. And of course, you don't have to write just so many tests if you do something like adding type hints and other things that just avoid you tons of tests that verify things that could have been caught at compile time. But I guess just a matter of opinion then. Testing static methods. People always complain, oh, but I cannot test this and this is not testable. Everything is testable. And there's a much more advanced talk I've seen years ago, which was about testing untestable code. And it was some really weird things you can do to test the most untestable code. So there are not really any excuses. So with Mockery, you can test, static methods. You can see what you receive from there. So there are tools for every situation. And then if you're stuck, you can bounce ideas with people that maybe you don't know. At conference is actually a great place to bounce ideas. So next time you're having coffee, chat with someone, talk about the issues that you're having with your code base, and they might have already solved the problem. So it's really interesting. Like every time I go to a conference, I learn something, and I've been at it for a very long time. So check whether this has been done before. Sometimes it's just a Google search about the concept will reveal that there are already maybe 20 different solutions for the problem. And think about different approaches. And when you have a different approach, you can just write a proof of concept to see if that approach is viable in your situation, and only then you can move forward with it. So try new things. Takeaways from this talk is start by making a strategy. If you touch the code, you have to refactor it. There are known tools and methodologies. So there's a book actually by Martin Fowler. It's actually on my next slide. There's a book called Refactoring, Improving the Design of Existing Code. So step by step, you can see the different manipulations in the code you can do in order to progressively refactor it. So really more on the code level examples. You can get inspiration from others, even people from different professions. A gardener might have solved a conceptually similar problem to yours. So just talk to different people about everything. You can get a lot of ideas like that. And refactoring, although very hard, it gets easier. As you get some experience, it becomes so easy that sometimes people will look at a piece of code and they will just throw up. And I look at it, I'm like, meh. So it gets easier. You develop a resistance to it, so it doesn't shock you anymore after a while. And it does get easier. You can do much faster the same things after a while. And when you are at your most desperate moments, remember that everything has a solution, and typically a very simple and elegant one. And you just have to step away from the code, take up a pen, or draw something on a whiteboard, talk with other people, brainstorm a bit, and you will find a solution that you may not have thought about, which is pretty simple. So just don't go head first into the code and see what happens. Think about it first. Read this book, very useful. I will tweet the slides, and also you can read more poems on my blog, but you cannot see it. But basically, Felina and afelina.com. So just Felina everything, and you'll find me. I'll tweet those slides for you right after this talk, if I can get any Wi-Fi. And yeah, I'm open for questions. Thank you.
Show your hands.
Hi, I'm working on a shop system which is based on Oxid, and basically the most stuff I do is deleting code, and that feels awkward. Is this normal?
Yes, yes. And I've tweeted about this many times. I show, like, hey, I just refactored some code, the tests pass, everything checks out, like we checked in the browser also, everything works, but we actually just deleted 2,000 lines of code. That is normal. And a friend of mine actually said, when I was discussing this, he said, oh, so you're not a coder, you're a decoder. So yes, if you're deleting code, you are on the right track.
Thanks.
You're welcome.
Further questions? I have a question.
Yes.
Does a legacy refactoring project ever stop?
I've never seen one brought to full completion of refactoring, simply because at some point you realize that you're pretty much where you want to be. You don't necessarily need to refactor the last bit. So it's that thing where the last 20% of what you're trying to achieve takes the most effort. I think it's a 20-80 rule. So yeah, it doesn't actually stop in the sense that you never finish this, but if you start with a full rewrite, then you're pretty much not going to finish it, because what happens is that the stakeholders, they expect value, and during that time you're not only not delivering any value, requirements change, the business changes. By the time you complete the new code, it might not even be valid anymore. And while you're doing this, you still have to support the current business. You still have to fix things in the legacy. And once you start writing shiny code, you don't really want to look into the legacy. So there's like a whole psychological factor also coming into play. So I would recommend really to start, refactoring bit by bit, module at a time. Because once you refactor a full module, you get the satisfaction of what you bring to the customer. I don't know if that answers the question.
Can you measure this 80%? Is there, or it's just a feeling you say, okay,
yeah, the 80%, yeah, it's more of a general rule. It's not necessarily measurable. But what is measurable is the impact on the business when you do refactor. So when I rewrote the billing module, the one that generates the invoices, I ran the billing cycle with the previous codes, and I ran it with the new code, which did not include the bugs. And I just did a spreadsheet that compared the output, and it was like thousands of dollars of difference. So you can measure right away the impact on the business.
Any further questions from the audience? Oh, up there.
Yeah, in the center.
Even if you manage to refactor your legacy code, how do you handle a somehow messed up database at the same time?
Yeah, garbage data is a real problem. The thing is, you cannot always fix the data, because if you fix it, there might be some legacy you haven't yet refactored that will depend on that. So the idea, if you are going to see the whole refactoring of the whole system through, if that is the plan, then try to sort of map the data in a way to decouple the database structure from your code, so that once you finish rewriting everything, you can just change the few places that defines how the data is, like what's the database schema, for example, and then you can do the migration in the database. But unless you're going to do that, you just have to find a clean way to handle all of those exceptions. Certain things are actual problem data that is just simply not caught in the legacy. So for example, let's say certain objects will be inaccessible because the query uses like an inner join and the data is null somewhere where it's not supposed to be null. So in those cases, that's an obvious bug. And if you find those things, then you can run a script to fix things. But in other cases, the error in the data is an actual feature. So for example, there was a situation where a database that is way too big to run any meaningful migrations, it had users that were associated to accounts. And the users were associated to, initially, users only had like a foreign key to the account. So a user basically belongs to an account. But then they changed things and they created like a many-to-many relationship. So they had a table for user accounts. But the problem is, so basically the user could have access to multiple accounts. But the thing is, which we didn't know, was that in case there is only one association, there will be no entry. Instead, they will go for the foreign key. So that was like a feature that they were handling, and we could not remove it also because then it would break other parts of the code. So those things happen. So that's one example. Does that help?
Somewhat.
Yeah. Well, it doesn't fix the legacy for you. It's just reassurance, I guess.
Actually, I have a question. Is there like a stage when we like rewriting is impossible and we just need to write a new application? And
yeah, well, some of the things I covered in the beginning, reasons for rewriting the whole thing is if you're taking something that is running locally, or like something that is not exposed to the web, and then you decide to do something new with it, where it's compiled in a way that you cannot decompile, so you cannot forward requests. You know, some situations make it impossible, and I did have to do a rewrite. But when you're going to rewrite, you have to agree with the business that you're not going to rewrite all the features. You're going to rewrite just the core of the business, because some features, even though they're there, might provide so little value that then rewriting them at this point makes no sense. Maybe they were relevant 10, 15 years ago, so they may not be relevant. So you have to rethink the requirements, rethink the value of each of those features or modules, the value for the business, the value for the end user, and go from there. So simplify, you know, to a minimum viable product, and then you rewrite. Because if you're going to rewrite a huge application from scratch, it's possible to never finish those efforts, just because it's so massive.
thank you.
You're welcome. Yeah, we have time for one more.
Hi, great talk, by the way. I really love the idea to extract the specification and check it back with the client, but I feel that we are on a very high abstraction level there. And usually the original programs aren't around anymore, and there's a lot of complexity in the code, but I can only check back with process owners and have business rules on a very high level.
Yeah.
How do you solve that?
Yeah, well, it is going to be on a very high level. You have no choice. Basically, when you're rewriting a module, for example, you're going to rewrite it the way the stakeholders want to see it happen. So you're basically validating this against their business rules. Just validate the business rules, like highest level. ERDs, not even DFDs, you know, like ERDs, some decision trees, things like that. A couple of flowcharts, walk them through it on a very high level, and then they will spot the problems. They will sometimes even grab the pen and say, "Oh, can we move this and there, this there?" So business people actually are able to understand certain diagrams if you explain it to them. So yeah, it's going to be very high level, and from there you're going to design the other stuff where you think more about the architecture and infrastructure and whatnot. But yeah, what you're validating with the clients are the functional specifications.
All right, thanks.
You're welcome. All right, and it's 10:45, so sorry, 4:45, different time zone.
Okay,
It's 45 past.
Thanks for now.